Hey everybody, I'm going to make you a final exam review. I'm sorry I couldn't do it during a live session. Unfortunately, with summer being the way it is, it's crazy to try to get the schedules lined up. So I'm going to do it every couple of questions, and I'm going to post it to a YouTube playlist so you can watch it as much as you want. All right, so let's go ahead and get. So the first question is, consider a binomial experiment with 8 trials where the probability of success is 0.35, okay? So remember, binomial is basically a yes, no. Did it occur? Did it not occur? Right? And it wants me to use SALT to find the probability that none of the trials occur. The probability of success in the 8 trials was nothing. And then R is greater than or equal to 1. So let's go to SALT. Okay, and I'm going to go here and I'm going to do binomial distribution. I'm going to put 8 in and I'm going to put 0.35. And I want the probability of success to be 0. Okay, so this probability, I'm going to move all this out of the way. Sorry for all this stuff. The probability for success is right here, which is the yellow, and it is 0.03186, which becomes, because they wanted 3 decimal places, 0.032. Okay, so then the next question asks, let me go to it, what's the probability of the greater than 1 or greater? Okay, this is really easy to do, and I'm going to bring my calculator up, okay? Okay, so what I'm going to do is I've got 0. So then what I'm going to do is I'm going to do 1 minus my last answer, 0.032, and then I get 0.968. But what does that mean? So let's go back to SALT and I'll show you what it means. So less than or equal to 0 or equal to 0 is the yellow. 1 or greater is the blue. And instead of me having to run it a bunch of different ways for each one, all you do is find 0 and then subtract what the probability is of this 0 from 1 to give you the answer. So again, all I did is I did 1 minus the probability of 0 gives me 0.968. So that's how you solve that one. So that was number 1. Okay, number 2. All right, consider each distribution. Determine if it is a valid probability distribution. All right, so I'm going to add these together. Remember, I'm going to add the P of X together. So I get 0.24 plus 0.64 plus 0.12, and I get 1, which is correct. So yes, it's the probability sum equals to 1. So let's do part B. So now I'm going to do 0.24 plus 0.64 plus 0.13. Okay, and what do I get is 1.01, and that cannot be a probability because remember, probabilities have to add up to 1. So I'm going to say no because it doesn't add up to 1. Okay, number 3. Compute the expected value, remember, which is the mean, and then compute the standard deviation of the distribution. Okay, I'm going to do the mean, the standard deviation. They give you a wonderful way to see it. So I'm going to do this. I'm going to do 0, which is X, times 0.65, parentheses, plus 1 times 0.20 plus 2 times 0.15. And if I do that, my expected value or my mean is 0.5. Okay. And then if you go down here, it shows you how to do it. So I just did that in the calculator right here. And all they did is they did what I did. I just made it a little bit easier to understand. Okay. And then here's how to do the standard deviation. Remember, you're going to take what your expected value was. You're going to subtract each X from it and then square it. And then you just keep going. You keep doing all the stuff together. I would follow these steps. I would either take a screenshot, because remember, the final exam's not proctored. Figure out a way to do it. Screenshot it, do whatever. If this one causes you issues, I would wait till the last, if you're running out of time, wait last to do that. But remember, you just got to follow these steps. So you've got your probabilities, you do your expected values, and then you multiply it times your probabilities. And that's what you get. Okay, and you take the square root of it. All right, so that was 1 through 3.